Alright, welcome. Pre-calculus, this is review worksheet 2. This is to help you guys prepare for the 2A test, which is coming up. And the questions on here are kind of an overview of everything we've done from this chapter so far. So if we're getting started, all the way back from 2.1, we want to be able to evaluate a function at a given value or expression. So in this case, it tells us we want to find the value of the function when x is 6. Now this is my actual function. So it says when I actually plug 6 into this, what am I going to get? So the value of the function when x is 6. From here, all we're going to do is just replace wherever there's an x in our original function, I'm going to put 6 in for it. So in this case, we're going to get 6 times x, which is 6, squared minus 1. And to find the actual value, now we just need to simplify. So from here, right, we're going to get 6 times 6 squared, which is 36. And then just minus 1. And simplifying even farther, 6 times 36 is 216. Minus 1 is 215. So the value of the function when x is 6 is 215. Now just like we did it over here we're saying I want to find the value of the function when I'm plugging in a minus 3. So I have some number and I'm subtracting 3 from it. But I want to know what the value of the function is when I actually plug that in. So the value of the function when x is a minus 3 is just a minus 3 squared, because remember it's x squared, plus 6. And from here, remember when we do, that's a binomial squared. So that's really saying a minus 3 times itself, which is a minus 3. So when I simplify this, we're going to get f of a minus 3 equals, remember it's going to be first, so I'm going to go first, and then outside, which is a times 3. So in this case, when I'm going to get negative 3a minus 3a, which is going to be minus 6a total. And then negative 3 times negative 3 is going to be a positive 9. And then don't forget this 6 on the outside, so we still have that plus 6. So now the only simple thing I can actually do is I can add my 9 and my 6. So I'm going to be left with a squared minus 6a, and then 9 plus 6 is going to be plus 15. And I can't simplify anymore, so the value of the function when x is a minus 3 is going to be a squared minus 6a plus 15. So hopefully we're doing okay. Confidence level is good on that one. So from here now are the other things, some other stuff we did in 2.1, is we want to be able to find the domain of a function. So you want to ask yourself the question, what x values work? Like what x values can I actually plug into this and get an ordered pair out of it? So in this case, when I see square roots, the only thing I can't actually have under a square root is a negative number. I can have 0 and I can have any other positive number. So what I'm really saying is this whole thing, whatever this comes out to be, is it has to be greater than or equal to 0. So for right now, so we're saying whatever that is, that number is, negative or 3x minus 9, this has to be greater than or equal to 0. So from here now I want to get x by itself. So I'm going to add 9 to the other side. So we're going to get 3x is greater than or equal to 9. Then dividing by 3, we're going to be left with x is greater than or equal to 3. And if it helps you, I really encourage you to do a number line on this, because we know how to do that. So if we're going to do a quick number line, we have 3 on there. And we're saying x has to be greater than or equal to 3. So any number that I want to plug in has to be greater than 3. That's actually all of these values over here. And then since it's greater than or equal to, I'm going to do a bracket. So when it says on these, we have to write our answer in interval notation. So in interval notation, from here, we're going to say, I can plug in any number from 3 to infinity. I can get that from my graph. And those numbers will actually produce a number that's greater than or equal to 0. So notice if I picked a number outside of, not in this interval, like say I picked 0. 0 is not in this interval. When I go back here, I'm going to get 3 times 0 minus 9. Square root of that. 3 times 0 is just 0 minus 9. Notice how I'm going to get a negative number under my square root. So in this case, that's why our interval is all numbers from 3 to infinity. Because when I plug in 3, that's when I actually get 0. And then everything past that will produce a positive number. So in this case, my answer for that one is just 3 to infinity. Now, kind of like over here when we said anything under a square root had to be greater than or equal to 0, notice on this one we have a fraction. The only numbers I can't actually plug into this are anything that makes the denominator 0. So basically what we're saying is x squared minus 9, whatever number that actually comes out to be, just can't equal 0. Because I can have negative numbers on the denominator. I can have positive numbers. The only thing that makes it undefined is when there's actually a 0 there. So right, simplifying, all we're going to do is add 9 to the other side. So we're going to get x squared is not equal to 9. Then from here, taking the square root of both sides to get x by itself, we're going to get x is equal to plus or minus, because when I take the square root, remember we have that plus or minus, and that's a little off. But notice, so from here, right, we're going to get plus or minus. Square root of 9 is 3. So from here, right, I'm going to write it up here. So we're saying if we go to our number line, the only numbers I can't have it be are actually negative 3 and 3. So I can't have it be a negative 3 or 3. So those are open circles there. But I can still plug in anything less than negative 3. That's totally fine. I can plug in numbers in between those two. So those are okay. And I can plug in numbers that are greater than 3. I just can't have any numbers actually being equal to negative 3 or 3. So interval notation on this one, I have to go from negative infinity all the way up to negative 3. I can go in between negative 3 and 3. I can plug in numbers in that interval and it'll work. And I can plug in anything after 3. So from negative infinity to 3, union negative 3 to 3, union 3 to infinity. That's actually, those are all the numbers that I can actually plug into my function and actually get a value. So in interval notation, that's what the domain of number 4 is. So the last thing we actually did in 2.1, or one of the other things we did in 2.1, was being able to study the graph of a function and answer various questions about it. This is a big part of your test tomorrow, so we have 2 examples on this one. So the first graph, this is our graph, and our first question says, evaluate the function when x is 4. That's how we'd read this. So when I'm looking for this, on my graph, I'm going to go to where x is 4. So I'm going to go 1, 2, 3, 4. So if I drop down here, I have an ordered pair right there. So if I go over 4, 1, 2, 3, 4. If I go down, it's kind of hard to read on your graph. But that point right there is negative 3. So when x is 4, it's saying y is negative 3, or the value of the function is negative 3. So there's that one. I'm going to erase that actually. So now, just like want to find the value of the function when x is 4, now I want to find the value of the function when x is negative 2. So when x is negative 2, I'm going to go left 2. That's the point right there. And the y value on that is actually 0. So when x is negative 2, y is 0. That's all we have to do for those two. Now, this next one is a little bit more tricky, but not too bad. So this is saying, where is the function? Where is it less than 0? Or in this case, f of x is really my y value. So where are all my y values less than 0? Well, from 0 up, because y is up and down, if y goes up, that means that's where all my y values are going to be positive. So I care about all my values down here, anything below the x-axis, because that's where all my y values are going to be negative. So notice, all my x values along here, all the way up to here, this point right here, all of those are going to have negative y values. So in this case, this is actually going to be an interval. So from when x is negative 8, and actually, that's going to be a bracket, because I actually have an ordered pair there. So from when x is negative 8, all the way, these all have negative, 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 until this point right here, which is at the point is when x is negative 2. I'm going to have negative y values. I can't actually include negative 2 because that has a y value of 0, and we're doing strictly less than 0. So continuing, I need to check to see if any of my other function has that. So if I notice, all of these have positive, 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 until that point right there, which is when x is 2. So from when x is 2, because that has a y value of 0, all the rest of these points actually have a negative y value. So in this case, all the way until when x is negative 8. And then I can have a bracket on that because I actually have a point there. So all of those y values in that interval have a negative or less than 0. So that's all we have to do for that one. Now the next question says, where is f of x equal to 0? So where on my graph is y equal to 0? Well, when y is 0, right, if it's up here, that's positive, that's my x-axis. So in this case, we're saying when x is negative 2, and when x is 2, that's when we have a y value of 0. Because the ordered pair of this is negative 2, 0, and the ordered pair on this one is 2, 0. So when I ask where is f of x equal to 0, it says at what x values. So same with this next one. This one's saying, where on my graph do I have x values if y is 2? So if y is 2, I'm actually going to go up 2. And the y, I have a point there and a point there, notice, when y is 2. So what are the x values on those points? Well, in this case, right, we'd go right there. That has an x value of 1. So I'm going to have an x value of 1. And if I go to the other point, that has an x value of negative 1. So when x is 1, I have a y value of 2, and when x is negative 1, I have a y value of 2. Similarly, for this next one, for what x values or value is f of x equal to negative 3? Well, I want to go down to where y is negative 3. 1, 2, 3, that's right here. And I say, okay, well, what x values have a y value of negative 3? Well, if I go over here, I have a point there, and I have a point there. So now I want to ask, what are the x values on those ordered pairs? Well, in this case, I'd go over 4 and down negative 3. So when x is negative 4, I have a y value of negative 3. And when x is 4, I have a y value of negative 3. Now, what symmetry, if any, does f of x have? So remember when we were talking about even and odd functions, right? We either had, it was symmetric around the origin, it was symmetric over the y-axis, or it didn't have any. In this case, if you notice, if I flip this left part of my graph over my right part, I actually have y-axis symmetry. Because if I were to flip that over, it looked like the same function. So in this case, when I ask about symmetry, this actually has y-axis symmetry. And then for this next one, if f of x even, odd, or neither? If it had y-axis symmetry, that means it's an even function. So next question, what is the local minimum as an ordered pair, or local maximum, excuse me, as an ordered pair? So I'm looking from anywhere in my graph that goes from increasing to decreasing. So from here, until this point right here, I'm going from increasing to decreasing. So over here, the ordered pair on that point is actually the point 0, 3. So at the point 0, 3, I have a local maximum. Now I want to figure out domain and range. So domain, remember, is left to right, or left to right, and range is bottom to top. So domain is the leftmost part of my graph to the rightmost part of my graph. So notice, when x is negative 8, that's when my graph actually starts. So when x is negative 8, and then I have ordered pairs all the way over till here, the x value on that is 8. So from when x is negative 8 until when x is 8, that is my domain. Because those are all the possible x values I can plug in and actually produce an ordered pair, or actually produce my graph. And then similarly for range, this is the lowest point of my graph to the highest point of my graph. So if we notice, this is the point of my graph where it starts. So the y value on that is actually -5. So the lowest y value I'm going to get is -5. I'm not going to get any y values lower than that, meaning I'm never going to get a y value of -6, -7, anything past that. So when y is -5, that's when I start getting y values all the way up until this point, which is when y is 3. And I can actually have brackets because I've ordered pairs at those points. So in this case, that tells us what my domain and range is. So that's the end of page 1. Stay tuned for page 2.